Now 28 and 30 and 32 are a little bit different, and 28, I gave you 28 because it tells you to go back and look at the example in the figure 4.94, and that's on page 428. So when a problem refers you to go back, you should go back. But essentially, it's saying that sinusoidal motion can be modeled with one of these two equations. And these are really the same thing that we've been doing. Omega is what we've called B up until now. But in science, B is really what we call omega, which we learned about in section 4.1. That's angular velocity. And on that page, it also says that the frequency, which we know is 1 over the period, the frequency is how many revolutions in a second, how many cycles in 1 second. Well, the frequency is also calculated as omega over 2 pi. Because remember, omega is B, and this is what we learned back in an earlier section. So this is really nothing new, it's just a new letter. Instead of using B, we're using omega. And so 28 says we have a piston, and the piston has a radius of 18 centimeters. And it turns with an angular velocity, so we know angular velocity is omega of pi radians per second. And the question says, what is the frequency? Well, the frequency is omega over 2 pi, so pi over 2 pi, which is 1/2. So it'll do 1/2 of a revolution in a second. The next question says, write the equation that models this. Well, if we go back and look at that other example, we can write the equation that models this, and we can write D, that's the displacement of the piston end, is going to equal A. A is the radius. So D is going to equal the radius, 18, times the cosine of pi times t. So that's the answer to part B. And then for part C, it says, how many cycles does the piston make in 1 minute? How many revolutions does the piston make in 1 minute? So if we know that the frequency is 1/2 of a revolution per second, that's what this number up here is. That's 1/2 of a cycle, or 1/2 of a revolution per second. Well, in 1 minute, if we multiply that by 60 seconds, because that's what 1 minute is, that means it's going to do 30 revolutions in 1 minute.